everyone. It's such an honor to be here. Really looking forward to sharing some interesting learnings with you all. So my name is Frikkie Snyman. I'm a mobile platform engineer at Relive. And I'd like to show you how we halved the total number of API calls being made from the Relive app. I first quickly want to introduce myself and Relive. At Relive, we're building an app that enables users to go outdoors in order to live a happier and healthier life. We do this by inspiring and motivating them to get out there. At the same time, we're also aiming to become the world's largest outdoor community. Relive currently has just over 17 million registered users, and as such, scalability is a primary concern. As for myself, I've been at Relive since 2018, initially as a full-stack developer and then as a tech lead, and for the last about 8 months as a mobile platform engineer. Now, the mobile platform team is a new initiative at Relive. At this team, we're focusing on providing our users with the best app experience possible. We're doing this by focusing primarily on performance, stability, and developer productivity. So as such, this implies that we're often diving incredibly deep into particularly React Native. So before we get going, I'm sure you've all heard that you're actually all judges on like a live action game show, and there's something to do with load shedding kits that you can win. So if I'm doing a terrible job, you're more than welcome to tell me by going to, well, not going to this QR code, come tell me in my face. Otherwise, if you think I'm doing well, please go and rate me as such. All right, so enough about me. So I want to show you how some basic understanding of React Native's life cycles can save you a lot of trouble. This also translates to how a basic understanding of the framework that you're using will save you a lot of trouble. So to best illustrate this, we're going to be building an app together. So as mentioned earlier, we're trying to get people to get outdoors, and we want them to live a healthier and happier life. So we'll build an app that motivates them to reach 10,000 steps per day. We'll use React Native to build our app, and we'll integrate using Apple's Healthkit to keep track of daily step counts. And it's 2023, so of course we're going to be using ChatGPT. So to break it down, when the user launches the app, we'll retrieve the user's current daily step count. Now, we want to provide a unique experience for every app launch, and we never want our user to see the same message. So to achieve this, we ask ChatGPT for an edgy message that'll motivate our users to reach their goals. Now, it needs to be edgy because, of course, it needs to be something that users take screenshots of and share to social media. This is how we achieve viral growth. And then, secondly, we're going to be asking DALL-E for a background image. Now, before we dive in, I just want to ensure that we're all on the same page when it comes to React Native. So for those unfamiliar, React Native is a framework that uses JavaScript and React to build truly native applications. It's really cool because it's cross-platform, so we have one code base for iOS and for Android and desktop and even TV and web nowadays as well. But it achieves this native app feel and performance by using native UI building blocks. So let's dive in. I've created an app here using MPX React Native init. So this simply gives us a buildable app with a top-level app component from which we can, start building the rest of our app. So here we have this app component, and this component simply on mount fires an effect that gets the step counts from Apple Healthkit. So this step count is then passed into our custom message component, which I'll get to in a bit, and then that is simply rendered. So now we get to the message component, and this is where the magic actually happens. So here we have two effects. The bottom effect that you see here, that's actually making an API request to DALL-E to get the unique background image that I spoke about earlier. And the effect at the top also fires on mount, and that gets the motivational message. But it's important to note here as well that this effect will refire if the number of steps for today has changed. And And yeah, now we have this component that gives us a unique message as well as a unique background image. So I'm sure some of you are keen, but it's not super relevant. But here I simply show how we basically build a prompt that we send to ChatGPT to get that unique message as well as the unique background image. So now let's take a look at what we've actually built. So as soon as we hit the app icon, we see the splash screen from React Native, and we see a little loader that I've added while we wait for those API calls to retrieve. And then we get our unique background and message. So this is pretty cool. So I think all of us now can, after this talk, go to LinkedIn and add prompt engineers to our history. So it's a pleasure. So for a brief moment, I'm going to be putting on my product hat. So at this point, we are relying on our users to remember about our app. Now, as any product manager worth your salt or worth their salt will tell you, it's never a good idea to rely on your users to remember about your app. So we can address this memory barrier by passively reminding our users about our app. And we'll do this by sending them weekly step count reports. So now we're going to be asking Healthkit to keep us informed of the user step counts by sending us updates while our app is in the background. So taking a step back, looking at React Native again, React Native has a JavaScript layer and a native layer. Now, these layers communicate through a bridge, enabling seamless integration of JavaScript code with native platform capabilities. Now, this app delegate file that you're seeing here is a very important file in the React Native world. This is essentially the main entry point to our app on iOS. And generally, if you're going to be adding native functionality to your code, this is where you're going to be dealing with it. So luckily in our case, we just need to add 2 lines to this file. So here we import the RCT Apple Healthkit header file at the top. And then we simply call initialize background observers. So we're using a package called React Native Healthkit here. And this line basically triggers a lot of magic in that package. I'm not going to dive into details here. I'm also not a maintainer of this package, so I'm not going to attest to any of its design philosophies. But the point is, after doing this, we do get background information coming from Apple Healthkit. So now we can get back to our comfy JavaScript world. So we now always want to know what the user's step count number is at. So to do this, we're going to be changing our function that we created at the beginning to also then send the step counts to our backend server. So we register a listener to process when we receive a new step count sample from Apple Health. Now, the important thing to know here as well is that Apple Health doesn't actually inform us what the value of the new step counts is. It simply informs us that there is a new sample to get. So we actually need to freshly retrieve that step count from Apple Health again. So taking this into account, we can just simply then reuse our function that we created at the beginning to then get the step counts from Apple Health. So before I show you what we've just built, I want to mention a few quirks about working with Healthkit. So Healthkit's background observers have different frequencies that you can register for. So some of them you can register for immediate updates, such as when new workouts are added. And others are limited by Apple. Like step counts, we can at most receive an update once an hour. So when we're developing, though, we don't want to wait an hour for an update to test our code. But we are developers, we're smart, and workarounds are in our blood. So basically, we can trigger a manual update of the step count trigger from Apple by adding a workout. So that then triggers both updates to come through. So of course, this means we need to update our app to also listen for workouts. I'm not showing how to do this here. Just keep it in mind for the demo that's coming up. And then lastly, this is also easiest to reproduce using a physical device where background app refresh is already enabled. So now with the disclaimer out of the way, let's take a look at what we've built. So in this demo, you can see a physical device running on the right-hand side, and on the left-hand side is our terminal running with the Metro Bundler server. So you can see there's no app running on this device, except I've just launched Apple Health. And now I'm adding a workout, and this will trigger our our workout and HealthKit, and step count update to reach our app. So as soon as I am done with my late night walk, there you can see the moment that I've hit add, we notice that Metro Bundler is now bundling our JavaScript file. And we can see on the left-hand side some logs coming through, and the step count has been submitted to the backend. So you can also see here that our app is not actually launched. It was only Apple Health that was active, and that sent a message through to our app. So that's pretty cool. But did you also notice now that we've now made 2 calls to OpenAI to get a message and a background image? So that's a bit funky, right? So let's understand what just happened. So HealthKit notifies our app that there is a new sample. This notification is nothing more than like just simply launching our app, but in a background state. So of course, this then implies that the app is that the app launch is dictated by how React Native set it up. So this means the JavaScript bundle is evaluated, the native bridge is instantiated, and then the top-level JavaScript code in the index.js file is executed. Now, our index.js file registers our root app component in the component registry. Now, as soon as the component registry has a component, it calls that component's render function. So now our root app components on mount hooks are fired, and at the same time, the root component renders our message component. So as shown earlier, our message component makes calls to OpenAI to get the unique message and background. So the worst of all of this is that this is all happening while the app is in the background and our user is not even seeing any of it. So now the first thing to ask yourself when you encounter this kind of behavior, like, is this actually bad? You know, this was quite simple to implement. We still seem to process these background events that come in. And, you know, that's kind of the desired result. But the thing is, yeah, this is quite bad. So to understand why this is bad, let's take a look at what like the potential impact is of this behavior. So if you'll allow me to drop some fresh lyrics, the best things in life aren't free, as demonstrated by ChatGPT. So ChatGPT's costs are based on tokens. Now, these tokens are about as mystical as the non-fungible ones from last year. However, our app seems to use around 250 tokens per message, which in turn means that we are paying around half a cent to get a message. So on the other hand, DALL-E more simply is 2 cents per image. Now this brings our app launch to cost around 2.5 cents per launch. So now we're going to make some assumptions. Apple notifies our app at most once an hour about the new step counts. So we'll assume that this equates to around 14 updates per day, naively assuming that people get like 8 hours of sleep and 2 hours of chill time. We'll also very optimistically assume that on average our app is open twice a day per user. So then, to determine our monthly costs, we simply need to know how many times our app is launched in the span of 30 days, and then multiply that with 2.5 cents. So now I'm going against my therapist's advice, and I'm going to project. So let's say we get about 1,000 users. Our app now costs $12,000 to run. If we achieve that viral growth that we're hoping for, we'll be paying $120,000 for 10K users. So things aren't looking all that great for our business plan. But there's some good news. If we can reduce the number of API calls made to OpenAI, maybe our app can still be viable. So let's first set some goals for this fix. So we want to retain the HealthKit functionality. So simply removing HealthKit is not a fix in this case. Secondly, we want to remain in the JavaScript layer. So native code is scary, so we want to avoid it. And building business logic in the native layer also breaks the paradigm that React Native sets out to achieve. Duplicating business logic is bad. And then lastly, we want to stay in business, so we don't want to lose too much money. So of course, I've just mentioned that we want to avoid the native layer. This doesn't mean that we shouldn't investigate the possibilities. So on the native layer, we could prevent instantiating the bridge when the app is launched from the background and instead process the updates from Healthkit on the native layer. But then we'll probably need to create some patches for React Native, resulting in a much more complex app. Secondly, this would mean that for any background processing that we want to do in the future, which might include Android, that would again result in duplicate business logic. On the JavaScript layer, we do have some options. So firstly, React Native provides the isHeadless property. Now this is useful exactly for processing in the background, but this is only available on Android, so can't use it. Secondly, maybe we can pass a flag to React Native when the app was launched from Healthkit. Sadly though, there is no metadata for when the app is launched due to a Healthkit update. Instead, the app is simply, as mentioned earlier, launched. So this leaves us with one last option, a higher order component. So here we introduce an app state wrapper. This component simply renders its children if and only if the app has been confirmed to be in the foreground. So the app state wrapper utilizes the app state class from React Native, which has a current state property that is continuously kept up to date. Now the moment when the current state goes to active, that is the moment when this component will then render its children. So now let's take a look at how our app now processes an update from Healthkit. So again, we manually add a workout to trigger this sync. So as you can see, I'm quite fond of going out late at night. My wife doesn't like it, but it is what it is. If you need to reproduce Healthkit issues. So as soon as I hit add here, we'll see on the left-hand side our app launches, and it does again process the update. And then just to confirm here, as soon as we open the app, then do we only make the calls to OpenAI at the bottom. So zooming in, if we take a close look at the logs from what I've just shown, so here you can see the app is opened, but our app state wrapper logs that the app has not been active yet, so it's returning null. At the same time, we are still able to process and send our step counts to the server. Once the app goes to the foreground, the app state wrapper now mentions that the app has been active. So only now do we see the API calls being fired off to OpenAI to get that message and background image. Now, what does this imply for costs? So now that we're only making calls to OpenAI when the app is in the foreground, it essentially means that our previous 16 daily app launches really is now just 2 launches per user. So suddenly we're now only paying 1.5K for 1K users, and in case of virality, we're only paying 15K instead of 120. So of course, it's easy to cherry pick an example. So I want to show you how this exact scenario played out at Relive. So currently around 10% of Relive users have Apple Health connected. And subsequently, we receive step count updates for them. Now we use these step counts for users who'd like to set it as a personal goal, and they get these nice progress charts on the right-hand side. And this is a feature that we've introduced about 1.5 years ago. Now, since we've released this app state wrapper, the absolute number of API calls being made to our mobile backend has halved. So I want to take a moment here to appreciate how a feature that was being used by 10% of our user base had this amount of impact. So of course, this drop in API calls is the biggest gain, and the reduction of costs on our infrastructure is directly correlated to this drop. So taking a couple of steps back, I also want to point out the thing that caused us to look into this in the first place. So Relive prides itself in the fact that it is data-driven. Most all product and tech decisions are made based on some kind of data, whether it be experimentation or otherwise inferred. This means that analytics is a primary concern at Relive, so much so that even developers at Relive are expected to be able to query and understand analytics at Relive. Now, this has proven countless times to be very effective for debugging and finding other issues. So because of the importance of analytics at Relive, it means that for each flow in the app, developers are consciously firing events to give us a lot of insight into how users are using our app. These events are passed into AWS Pinpoint, and from AWS Pinpoint there is some magic that probably warrants a talk on its own, so I won't dive into that here. But the point is, all of this ends up in Redshift, and where there's some processing done on it, and it's made queryable. Now, the important part to note also is that all of these events include like a ton of metadata around the state of the app, and in particular, it includes whether the app is in the foreground or whether it's in the background. So with this in mind, we started to notice that often when inspecting weird sessions, that a lot of things were happening in the background. So this triggered a smell, and upon validation, we found that more than 80% of our most occurring API endpoints are called while the app is in the background. So as you can see on the chart, the blue bars are when the app is actually in the background. So once again, because of the analytics pipeline, once the fix was released, we were able to confirm that it has indeed been fixed. So the total number of background API calls on iOS dropped from 80% to 11%. At the same time on Android, we also saw a drop from 16% to 12%. Now this marginal number of background API calls is much more acceptable, and the parity between Android and iOS gives us the confidence that both platforms are behaving similarly. So to round it off, these are the key learnings that we've taken from this experience. So firstly, we've confirmed the importance of analytics. So having analytics that is clear and accessible is crucial. Establishing trust in that analytics pipeline even more so. This trust makes any reaction on a smell warranted, and it reduces the risk of barking up the wrong tree. Secondly, and more subtly, we've highlighted the importance of fully understanding the framework that is being used. This means always knowing and understanding the expected behavior. In this case, the expectation that launching the app would execute the top-level JavaScript when the step count sync was implemented was missing. So to take it further, the expected behavior must always be confirmed, and any discrepancies between expectations and reality should be investigated. Now this concludes my talk. So once again, feel free to tell me what an insightful talk this was, but do that via the QR code or the link. And yeah, that's it. Any questions? I'm also welcome to taking that. We have quite a couple of minutes left, so. Yes.
That you can justify $1.50 per user, even if they're not giving you money, or is it a subscription model? Like, how does that work? How do you make that decision?
Yeah, so you're talking about the ChatGPT costs.
Yeah.
Yeah. Okay. So that was just an example. I wouldn't recommend launching a business using ChatGPT in this case. It was just yeah. I don't know if that maybe answers your question already.
Is that not a feature that you have? Because that's a feature that you use in the app, right?
No.
Oh, okay.
Sorry, this was all hypothetical.
Okay.
I wanted to illustrate what the problem was. If I were to dive into how that exactly looked at Relive, we would have been here for 2 hours.
Okay.
This was just an easy way to like simplify.
Okay.
Yes.
Okay. Thanks.
Yeah. Any other questions? Okay. If you're too shy to ask, I'll be here. Yeah, thank you so much.